Hey guys, well, finally back, and welcome back to .NET. I think it's episode 8. I'm actually watching this on my other machine, so I just want to check the sound. So if you give me 1 minute, guys, just need to check sound. Let's have a look. Alright, cool, that sounds okay. That sounds fine, which is quite good. So, if you didn't watch my other video a while ago, I was ill for like a week, and then this week we've been doing loads of home improvements, so I ended up sanding all the floors in the house, sort of treating them, if you like, varnish. It's not really varnish, it's kind of an oil and a varnish. Redecorated the sitting room, which we weren't going to do, and now we're thinking about doing the hallway and things as well, so it's just kind of snowballed, but I took today off just to kind of catch up with stuff again, and literally just had a quick look through WCCF Tech and a few other things, and so there's a few stories to talk about, mainly around the high-end desktop market, which seems to be just going bananas at the moment. It's absolutely crazy. So that's where we're going to start. We're going to start with X399 and Vega, which is going to be announced officially by AMD at Computex on the 31st of May. So no surprises there. They did it last year with the 400 series of cards. Really looking forward to Vega finally being announced, and actually getting some live demonstrations of just Vega, and not a if you want an engineering sample of Vega, but an actual production card. They should have production cards there because they'll then be shipping. I would have thought if they talk about it in May, it'll probably ship mid-June, I would think. Maybe even before that. I would hope. They need something to come out, because let's face it, it's been sort of 2 years since a high-end GPU has come out from AMD. You can't really talk about the RX 480 or 580 as being, pardon me, high-end GPUs. So you're really looking at the Fury was probably the last, or Fury X was probably the last high-end GPU to come out from AMD, and that was a while ago. So they need something in the market, and something is coming in the form of Vega. So that's pretty cool. Looking forward to that. Very, very interested in X399, which is basically going to take on X299 from Intel. So this just kind of goes through the basics of it. There's another article we're going to look at, and yeah, so this is insane though. So these are CPU IEDs that have popped up out on the net. So 2 platforms, AMD Whitehaven, which will run a version of the Naples socket, so SR3 2, I think. So it'll be SR3 version 2, and Naples is SR3. So that's an what is that? That will be an LGA chip, I think, rather than PGA. So it will be landing grid array rather than pin grid array, which is what kind of consumer Ryzen is. So here we go. Core count: 16 cores, 12 cores, and obviously hyper-threading, or SMT, will bring that 16 cores up to 32 threads, and 12 cores up to 24 threads. Again, the only thing I can see letting AMD down here is core clock speed. So base clocks of around 3 gigahertz, under 3 gigahertz for the 12 core part, which is a bit odd, and then kind of boosting up to 3.6 or 3.2 for the 12 core part. That boost clock, it might be a bit misleading, because it's probably not going to boost all the cores up to 3.6. So again, I'm kind of being let down a little bit by core clock speed, but to be fair, if you buy a 16 core chip, you're not buying it for gaming, you're buying it for other things. So the sheer amount of processing power you're getting there should make up for that core clock speed. And again, if you can get this thing overclocked to say around, I'm going to say conservatively around 3.6 on all the cores, then you're in a good place, I would say, for that kind of thing. So moving on, more stuff about AMD Ryzen and its X399 stuff. So they're going to launch their HEDT CPU SKUs. So 16 cores, 12 cores, I think. I'm not sure if there's a 10 core variant, but they're called Threadripper. and they are going to be on a 4094 pin socket in June. So this article here kind of just talks a little bit more in detail about what we were discussing a minute ago. And again, it's basically their answer to I feel like Broadwell E, or what will be Skylake X and Kaby Lake X. But yeah, absolutely unbelievable. 16 cores, 32 threads, and sorry, I got it wrong. It's SP3 revision 2. So the Naples socket is SP3. It has the code name of Whitehaven, which we talked about a minute ago. Where are we going? There's some pretty cool stuff. So this just gives you the comparison. Essentially, the Naples parts support more memory, can support 2 nodes or 2+ nodes, which is not surprising because they're server parts, and they use a bit more power. The Threadripper, I'm assuming this is talking about the 16-core variant here at 180 watts and more. So 180 watts, I'm assuming there'll be different SKUs. Maybe there'll be a whatever they want to call it, X, which will go above 180 watts, and then a non-X variant of that 16-core chip, which will kind of be around 180 watts. Pretty cool though. So that's bringing quad channel memory support, which a lot of people were wanting. I certainly like quad channel memory. I like being able to stack it up. Block diagram looks pretty normal. Nice to see a lot of the PCI lanes are actually going directly into the CPU and aren't being limited by this by 4 connection to the chipset. So that's pretty cool. So there's still still PCIe lanes going into the chipset, but not many. Sort of, SATA, PATA, and HDV cam. So by 16 lane, a by 1 lane. But the majority of your lanes, including one for an M.2, a by 4 slot for M.2, going straight into the CPU. So it's not going to be limited by this link here, by this by 4 link. Quad channel memory, pretty cool. 16 gigs per channel by the looks of it, which is impressive. Well over 100 gigabytes of memory there. And then they just go on to talk about it in a bit more detail. Again, the details aren't all there because AMD haven't officially come out and launched this. But then, so Summit Ridge, that's Ryzen, what we're using now. So it just gives you a comparison there. So pretty impressive, really impressive. What I'm most impressed about, what I'm glad to see is, I was right, it is LGA rather than PGA. So yeah, the 16-core chip will be LGA. Really like the fact that quad channel memory is coming. We need that, or I like that, being able to load up your machine with memory. 32 megabytes of level 3 cache is unbelievable. That is more than what Intel are offering on Skylake X, but we'll get to that in a minute. And level 3 cache can make quite a big difference. It can almost make up for a lack of frequency on the CPU, especially if you're doing a lot of multitasking. Quite impressive there. So yeah, really looking forward to this. This is apparently going to launch in mid-2017, so that makes sense. So end of June, I would have thought. How much will it cost? I have no idea, but if it scales linearly with, say, if you take this 8-core sort of top end 1800X for $480, $500, probably find them cheaper somewhere else now. I would assume that this 16-core chip is going to scale linearly. It might not. It might. So I would imagine you're probably looking at around the $900 to $1,000 for a 16-core CPU, which is not bad, and it's still going to be cheaper than the kind of top end offering on the Skylake X platform, which is, I think it's 12 cores, 24 threads, which is probably going to, Intel will probably charge about $1,500 based on previous pricing that they've done in the past. So you're still going to get very, very good value out of this Threadripper CPU, despite the fact that it's probably going to cost $900 to $1,000. It's still giving you more cores, more threads than Intel, although it's going to be slower. The clock speeds will be slower, but still, more cores, more threads is what you're after if you're buying anything above. If you're buying 8 cores and above, you're not a gamer. You know, you're buying this to do other things, multitasking, productivity. So more cores is better. Like, you know, you might be doing virtualization, for instance. You might be running virtual machines in the background that are running a NAS in the same machine that you're editing on, etc., etc. More cores, more threads helps with that. Core speed doesn't necessarily help with that because you don't have the cores and threads free to assign to that virtual machine. Anyway, that's that dealt with. Very excited. I was going to check to see 2 people are watching. Guys, I am checking on the chat, so if you've got anything to say, I will pick up on it. I've just got to kind of look between the 2 machines. So let's move on anyway. So we talked about AMD and their HEDT high-end desktop CPU. So let's talk about what Intel are doing. So this is on video cards. This is quite a nice, very compact little article where they're just talking about X299. So interestingly, I think the most interesting thing about this for me, because everything else is kind of what you'd expect from Intel, iterative, advanced, not much else really. The interesting thing for me is that the Kaby Lake X variants are, no, oh god, I need to get this right now. 4-base Skylake, yeah. So the Skylake X Extreme chips, they are going to be called Core i9s. So they're getting rid of the i7 and they're going to i9. I think that's just for market segmentation, because before, you know, like with me with my 6-core Broadwell E chip, it's just an i7 6800K, so it just the kind of the number just steps up, but there's no real market segmentation in terms of kind of, you know, to denote that it's an extreme chip, if you want, or an enthusiast grade chip. So that's what they're doing with this Core i9 business. So they're fairly normal. Intel are doing what they always do. They're like, yeah, you can have your 6-core, your 8-core, your 10-core, and oh, we need a new top end market. So the 7920X is going to be 12 cores, 24 threads, out in August. You know, when you look at what AMD are giving you, you know, 16 cores and 32 threads with twice as much level 3 cache, the same amount of PCIe lanes, this thing's probably going to be a bit faster than it in terms of turbo clock speed, but it's also probably going to cost $1,500. So nothing really exciting. I mean, they're just pushing you on to a new platform. They're moving you from X99 to X299. They're forcing you to do that because they're changing the socket. They're adding an extra 2060. Yeah, they're adding an extra 33 pins to the socket, so it'll be LGA 2066 instead of 2033. Which meaning you cannot use a Broadwell E, etc. backwards chip in an X299 motherboard, which I think is a bit shit, because people have spent good money on these CPUs, and it would not have been hard for them. I mean, an extra 33 pins doesn't get you a huge amount in the grand scheme of things, let's be honest. Not a lot. Certainly you don't need an extra 33 pins to run an extra 2 physical cores. It's that simple. That's my view. I think it's pretty bad. I think a lot of people would have moved to X, like for me, for instance, I would have probably bought an X299 motherboard for my 6800K just to get the extra functionality that comes along with it. But now I'm locked out of that. Now if I want to do that, I have to buy an overpriced CPU, because let's face it, these things are, all of these chips are probably going to keep the same pricing stratification that Intel have always had, and at the moment they look overpriced to me. They do look overpriced. I mean, who's going to pay $1,500 for this Core i9 7920X when you can probably get the 16-core Threadripper part from AMD for probably around $1,000? Who's going to do that? You know, so I think Intel needs to look at their pricing, and they really need to stop screwing over the customer. I understand that they want to move platform. I understand they want to move to X299. I have no problem with that. But the fact that they've closed out everyone else from that move who've already moved into the enthusiast market seems a bit strange to me. It's a bit like what Nvidia did with Pascal and releasing a Titan right at the start, $1,200 card, and then, you know, sort of a year later, 10 months later, they released a 1080 Ti for almost half the price practically of that Titan. That is basically a better card. And then a few weeks later, after everyone's gone out and spent all their money on that bloody 1080 Ti, they release the Titan Pascal, which just tanks everything. But again, that's another $1,200 graphic card. It's like, there's only so much consumers can take. And I really do think Intel are on the thin edge of the wedge here with this. I mean, these Kaby Lake parts, I just do not see the point in these. Why are these quad cores? I mean, that's a quad core with 4 threads on X299. Why? The 6 megabytes level 3 cache, 16 PCIe late. I mean, why the hell is that on what is going to be a $250 plus motherboard? Why would you do that? Why? I don't understand. I don't understand these two parts here. The 7640K, 7740K, I think are redundant products. I don't know who is going to buy these. Really, I mean, I know they're being, Intel are talking about them in this next article. There's a better, explains it a bit more. Here we go. They're talking about them being the fastest quad-core chips. Like, quad-core chips are dead. You know, you should not be buying a quad-core chip with 4 threads, guys. There's no point. Software is going to be moving on very quickly. i5s are already struggling. I mean, what can you can play games with an i5. You struggle to play a game and stream it and do something else. So I don't see the point in spending good money on a part that's probably going to be obsolete in a couple of years. And I mean, what are you going to get? You're going to get an extra few hundred megahertz out of this. The i7 possibly I see at a point, and the true i7, the 7740K, because it is 4 cores, 8 threads, and I think that is the minimum anyone should be buying. I would not buy anything probably less than 6 cores now and 12 threads, just for my workload, for what I do. I would find it too frustrating, you know. And even then, this, why is it on X299? Kaby Lake's going to be coming out, not Kaby Lake, Coffee Lake's going to be coming out soon, which hopefully will move to 12 or 10 nanometers, and you should get better performance for less money on the consumer grade i7 that goes with that, I would have thought, than you will out of this. I don't see what this gives you. Some extra PCIe lanes, maybe? I don't even know if it does. Let's have a look. What are they saying? No, that's 16 PCIe lanes. Unless you're getting more on the chipset, that's pointless. Buying these 2 CPUs is pointless. These I understand. The actual, the Kaby Lake X parts, or sorry, no, the Skylake X parts, I understand, because that's an iterative advance. That's what Intel do. That's what you expect them to do, to take Skylake Xeon parts, rebrand them as enthusiast level parts, and sell them to the consumer. These parts here make no sense to me, and that is my moan about Intel done. I just don't see who's going to buy these guys. Anyway, moving on. Nvidia. Let's check the chat. So Nvidia, this is quite interesting. Jensen came out and was basically talking about Nvidia's graphics cards being like a game console, which is quite an interesting analogy. So he was saying basically defending their pricing, essentially, saying that, you know, people are willing to spend $200, $500 for a new game console, and the average Nvidia GeForce GPU price is less than that. He didn't actually come out with what the average was. Oh, here we go, $200 to $300. Then he talks about, so he's basically saying that a graphics card on average, mainstream, like most people buy a 1060, something like that, maybe a 1070 in the sale, so around $200 to $300. And then he discusses, you know, it's all about what you want to do. If you want to play 4K at 100, or you want 120 hertz or 200 hertz, you need more horsepower, so you need a dedicated GPU. You're not going to get that on a console. Even, I mean, so far, even things like Project Scorpio and stuff like that, I mean, I need to see it to believe it. I just do not see how they're going to get true 4K, not upscaled, not tiled, true 4K from the specs they're talking about. I think if Project Scorpio was to be true 4K, it would be a very expensive console that essentially no one would buy. You might as well build a PC. But anyway, back to Jensen. So he's basically defending their pricing here. I don't really get his argument, because I think, yeah, you're willing to spend maybe 400, I would say, at the most, on a, or say 500. I mean, to get a halfway decent machine that you're going to put a 1060 in or a 480 in, you're going to be spending a bit more than $500. So I don't really see where he's going with that. But it's quite interesting. He's talking about here about them NVIDIA trying to get into the esports and things like that. So trying to get into the lower end market, and I really think they're going to struggle to do that, because I think AMD have got that tied up. I think the lower end market is tied up by AMD, both in terms of mainly where the money is, which is going to be in consoles, putting chips and systems on a chip in consoles. They have it sewn up. They've had it sewn up for years. I can't see that changing. And then he just talks about, when people are buying stuff, like they buy stuff in the holidays and consoles and at Christmas and things like that. It's like, kind of don't really see the point of his comment there. I see this bit, it's all kind of, I mean, it's basically like he's saying, they're about half the price of a console. Not really at the moment. I mean, I suppose if you were to take us $200 to $300 at the moment, I mean, you could buy an Xbox One, the new one, or a Sony PlayStation, the new one, for that. So it's kind of don't know what he's getting at there. His numbers are a bit out of date. But I get this point where he's basically just saying that most of their money in terms of graphics cards comes from people buying graphics cards to play AAA titles, and that's what's going to happen. In terms of here, seeing if they can get into the lower end market, I think they've got a hard time dislodging AMD from there. So that was that. I just find that was quite an interesting story. Let's move on. So Volta is here. GV100, 12 nanometers. So they've had a node shrink. 5,120 CUDA cores. Unbelievable. 16 gigs of HBM2 with 900 gigabits of bandwidth. This thing looks like a beast. It is probably going to have a beast price tag to go along with it. This is quite old news, actually, guys. I wanted to talk about this last week, but I was so ill. I just didn't get a chance. Next generation. So yeah, they're kind of talking here about GV100 being used to look at next generation deep learning for AI. Unsurprisingly, apparently it's got 5 times improvement over Pascal. They're talking about they're talking about teraflops. I don't know why they keep doing this. Like, why do they keep? Why do companies keep comparing things to like 2-generational technology? 15 times peak performance of Maxwell. Well, it should be. Maxwell's 2 generations ago. I'm not interested in that. I'm interested in this comparison to Pascal. That means something to me. But Maxwell, I mean, you might as well. I don't know. You might as well compare it to like a 8800 GT or something like that. Interestingly here, though, that the performance surpasses 4 times the improvements that Moore's Law would predict. So a lot of people are saying that Moore's Law was starting to kick in that innovation was starting to slow down, but obviously not in the GPU market. And I think that's largely buoyed by more people getting into gaming. So they're getting money in from consumers buying cards so they can invest in R&D, and then also the huge amount of money currently that is being thrown at neural networks and deep learning and artificial intelligence, looking for that magical algorithm that will tell companies everything they want to know about us and let them know how to sell whatever they want to us. So a bit of a double-edged sword, but I mean, that's pretty much what's going to drive growth in that sector, I would imagine. For things like this, for the full GV100 GPU, it's going to be deep learning, it's going to be the enterprise space and R&D, research and design. But that's it. Pretty impressive chip, I have to admit. That's a block diagram for it. It's unbelievable. A bit of reorganization going on here, but not a huge amount. They're basically bringing in some efficiencies. I'll let you read through it yourself, guys. Like I said, I've kind of only read through this briefly, but it just looks unbelievable. In comparison, here's the Pascal Tesla 16 nanometers, so it's shrunk to 12, GP100, much bigger die, 1815 millimeters squared, way more transistors, 21 billion opposed to 15. Probably just trying to think roughly how much is that going to be more CUDA cores, 50% more CUDA cores. Yeah, about the same speed, but that's understandable because they're adding more physical processors to the die. This is impressive though. 10.6 teraflops peak floating point 32-bit compute power up to 15. But that is impressive. And then again, the 64-bit floating point is gone up by it's gone up by the same amount. It's up to 7.5 from 5.36. These are important for AI. These are both very important, especially the 60. Well, not so much 32-bit, but the 64-bit compute numbers are important for deep learning and neural networks. 16 gigs of memory, HBM2, slightly more bandwidth, same power draw. Pretty impressive. I have to admit, NVIDIA every year do come out with something that is fundamentally different and better than the previous generation. I'm not really a graphics card guy, but I do find the whole GPU market very, very, very interesting at the moment. Because let's face it, if it wasn't for Ryzen coming out and then Whitehaven coming out and Naples coming out, the CPU market's pretty dull. I mean, we've just been discussing X299 from Intel, and essentially it's what you'd expect. It's what they've been doing for years, whereas this is really interesting. A lot of money in the GPU market at the moment. And there it is there. It looks pretty cool. Throw the memory down the side. Huge die. Huge processor die. Unbelievable. But yeah, you should have a look at this article, guys. It's very interesting. So looking forward to that. Not looking forward to the price tag. I'm not sure when it will launch. Probably end of this year. Yeah, just says 2017. So we'll start shipping 2017. Not sure when. It says second half. So these are primarily going to go to the enterprise space this year, and then early next year we will start to see Volta consumer cards. Probably end of January, I would have thought. End of January, CS maybe? Yeah, end of January I think would be a good time to launch it. And finally, just checking the chat. I just find this really funny. So this is in Tom's Hardware, and every year they do a best CPUs, right? Okay, so considering what's happened in the CPU market, you'd expect at least one Ryzen CPU to be in there. But nope, this is it. I mean, this is just a joke. So, these are all Kaby Lake. So it's basically the entire Kaby Lake lineup is the best CPU to buy. I was like, how is that? Like, well, maybe the best Intel chip to buy, but not the best CPU. I mean, especially here in the i5 range, how they can recommend 7600K over like the R5 1600, I just don't get. I really don't understand that. I mean, there's a little bit cheaper at the moment, 250. Or is it? That's probably about the same price actually, but you're getting like 4 cores. And fair enough, this will overclock a lot more than the 1600. But I mean, in terms of use, like gaming, streaming, all the rest of it, it's just like, come on, guys, really? Well, they kind of cover their ass here. This list is for gamers who want to get the most out of their money. If you don't play games, then the CPUs on this may not be suitable for your particular needs. Yeah. It's just like, come on, guys. That's just bullshit. It is literally bullshit. I don't know what Tom's Hardware are doing here. And I mean, it's so obvious the omission of AMD here is deliberate. And again, covering their ass. The article about the 5 Intel CPUs starts with AMD's Ryzen has barreled into the CPU scene with a bevy of offerings that tackle Intel's i5 and i7 series with increased post-processing resources and often at a lower price point. Okay, so why is there nothing here? You know? I mean, similarly here, like an R5 1700, about the same price, destroys the i7. Absolutely destroys it. The game is fine as well. It's much better. I mean, taking the core clock speed away, I mean, you're probably looking at overclocked 7700K versus overclocked R7 1700. The 1700 is probably losing out now by less than 10% on average. But the value to performance to value for that AMD chip is so much higher than this. It's so much higher than this. I mean, it's got twice as much logical cores. It's just like there's no way. I mean, it is currently. I have to admit, currently purely gaming, 7700K is the king, right? So I can live with that actually, yeah. But this i5 here, and even this i5, the 7500. Are you kidding me? Why is that in the list? Like, I would rather pay the extra like 30 quid and get the 1600 non-X variant that will probably will outperform this or perform exactly the same as this. So yeah, again, don't get it. Just don't understand. And also, the boards are the Intel boards are very expensive. Intel charge a lot for a chipset compared to AMD. So yeah, this was just for lols, guys, just to let you know that even people you would think that are reputable sometimes come up with some pretty bizarre things. But yeah, this made me laugh so much. You know, and they justify all their choices. But I mean, come on, guys. Seriously, are you getting this is I mean, I read this and I was looking for the sponsored by Intel link somewhere, you know. It's just, and oh my god, I just watched the video picking apart the CPU recommendations article, and it's picking apart exactly. This guy's on the money. Yep, man, are you mentally retarded? Yeah, I agree with both these comments. It's just like, yeah, it really should have sponsored by Intel up here. It's just a joke, guys. But anyway, that's it. That is the news over. Hopefully the coverage will start to kind of recover some normality. So there's no comments, which is fine. So I'm going to get out of here, guys. I'm going to stop streaming and get on with the other things I've got to do today. I'm also off to see Alien Covenant. Can't wait to see that tonight. And then I'm thinking I might do my overclocking guide for Ryzen. I might do a live stream to do that, because I can do that now. I just have to figure out the capture. So I've got two machines, so I could stream from one and use the other one for actually showing you how to do the overclocking. I think that would be easier. It'd be easier for me than doing a video, and then if you guys had questions, you could just ask them directly in the chat. But I'll let you know about that next week, guys. Either way, I'm kind of hoping to have something out by the end of the next week on overclocking Ryzen, because it's well worth doing. It's really, really good chip. To the point that until I had to turn on my Intel machine today to use it to monitor the stream, my Intel machine's been turned off. I've just been turning it on to update. That's it, to update drivers. I haven't really been using it, so really happy with Ryzen at the moment. It's just such great value for money, which is why I find this article hard to swallow. Anyway, guys, I'm going to get out of here. Thank you very much for tuning in, and have a great week. Bye.